Hi, welcome to this presentation. The topic today is SURDS, and the question we are dealing with today is on simplification of SURDS. This is part 2. Part 1 we had already done in the previous video, and the question we have here reads, without using mathematical table or calculator, simplify the following, leaving your answer in SURD form. We have part A, root 3 over 1 minus cosine of 30, and then part B, root 8 over 1 plus sine of 45. Let's begin with part A. One thing I want us to take note of here is that 30 is a special angle. Special angles are 30 degrees, 60 degrees and 45 degrees. They're special in the sense that we can get their respective trigonometric ratios, that is their sines, cosines and tangents, without using mathematical tables or calculators. And for angle 30, we can obtain its sine or even cosine or even tangent from the following triangle. So consider an equilateral triangle with sides 2 units. So the base also is 2 units. But before I write that, let's have a line from this vertex here bisecting the base. So when it bisects the base perpendicularly, so that here we have 90 degrees. So that at this point we'll have 1, and this point also 1. And because it's an equilateral triangle, the angles here are 60 degrees, here also 60 degrees, and then the whole of this is 60 degrees, but this line bisects the angle here, so that at this point we have 30 degrees. Here also we have 30 degrees. Now consider this right angle triangle. The base is 1, the hypotenuse is 2, and therefore using Pythagoras theorem we can get the height, and the height is the square root of hypotenuse squared minus base squared. And hypotenuse squared is 4, base squared is 1, so 4 minus 1 is 3, and therefore we'll have the square root of 3. With this triangle we can therefore get cosine of 30. Before we get that, let's consider SOHCAHTOA. Now this just helps us understand the trigonometric ratios. S is for sine, and therefore sine is opposite over hypotenuse. C is for cosine, and cosine is adjacent over hypotenuse. And T is for tangent, and that is opposite over adjacent. In this question, considering the angle 30 here, because we have cosine of 30, adjacent side is this side, and that is root 3, and the hypotenuse is 2. So if we consider cosine of 30, then we'll say adjacent, which is root 3, so we have root 3 over the hypotenuse, which is 2. Now in place of cosine of 30 here, we will have to write root 3 over 2. So we are going to have on the numerator root 3, and the denominator we have 1 minus root 3 over 2. Root 3 over 2 is cosine of 30. We have already replaced it. So at this point, to make our work easier, we will have to eliminate the fractions by multiplying by the LCM, and the LCM here is 2, so we multiply by 2, and the same factor multiplies the numerator, and this therefore simplifies to 2 root 3 for the numerator, that is 2 times root 3, and then 2 minus root 3 for the denominator, that means 2 by 1 is 2, 2 by root 3 over 2 is root 3. So at this point we are going to simplify this by rationalizing the denominator. The denominator is 2 minus root 3, and therefore we'll have to multiply it by its conjugate, and therefore the conjugate is 2 plus root 3. Remember, it's only the sign that is changing. We maintain 2 and root 3 also in the second bracket. Now, we multiply the numerator by the same factor, which is 2 plus root 3. We are going to begin by expanding the denominator, and we need to recall the quadratic identity a minus b into a plus b is a squared minus b squared. Now this is a difference of two squares. We can take note here that in the first bracket we have a and b, the second bracket we have the same a and b. The only difference is that the first bracket we had minus and the second bracket we have plus. So we can see some semblance in this quadratic identity here for the denominator. We have 2 and root 3, 2 and root 3 in both brackets. It's only the sign changing negative and positive. So that means we can apply a difference of two squares on the denominator, and therefore applying the quadratic identity we'll have 2 minus root 3 into 2 plus root 3 is 2 squared, that is a squared, minus root 3 squared, and that is b squared. Remember, 2 here is a, root 3 here is b. So this simplifies further to 4 minus 3, that is 2 squared is 4, root 3 squared is 3. 4 minus 3 is 1. So that means we are done with the denominator. Going to the numerator, we'll have 2 root 3 times 2 plus root 3. 2 root 3 times 2 should give us 4 root 3, and then 2 root 3 times root 3 should give us 6, so that we have 4 root 3 plus 6. Once again, 2 root 3 times 2, that is 4 root 3. Remember, we are multiplying 2 by 2, which gives us 4, and then times root 3. Yet we also have 2 root 3 by root 3, and that gives us 6. So just take note that when you multiply 2 root 3 by root 3, that is 2 root 3 by root 3, this is what we are going to have. 2 multiplies by 1. Remember, 1 is here silently. Here we have 2 root 3, and here we have 1 root 3. It's only a single root 3. Therefore, 2 times 1, that is 2, and then root 3 times root 3, that is 3. And therefore, 2 times 3 is 6. And that is how we were able to get this 6 here. And therefore, we are going to have numerator over denominator. So for the numerator, we have 4 root 3 plus 6, that is this part here, and then the denominator we had gotten as 1, so right here. So when you combine, we have 4 root 3 plus 6 over 1, and this simplifies further to 4 root 3 plus 6. This can be rewritten as 6 plus 4 root 3. So the two answers are the same. So whichever way you wish to leave it. And that is for part A. For part B, we have root 8 over 1 plus sine of 45. Once again, 45 is a special angle, but for 45 we are not going to use an equilateral triangle this time round, but we are going to use a right-angled isosceles triangle, this one right here. So it's 90 at this point, and we have the sides. Here we have 1, this other side we have 1, and then these angles at this point we have 45 degrees, and here we also have 45 degrees. By Pythagoras theorem, the hypotenuse is base squared plus base squared, that is 1 squared plus 1 squared, and that gives us, or rather here we have the square root of base squared plus height squared, so that is the square root of 2. With this, we can therefore get sine of 45. Once again, let's talk about SOHCAHTOA. This time around, it is sine, and therefore sine is opposite over hypotenuse. Now, with respect to angle 45, if you position yourself here or here, so let's talk about this point. So if you position ourselves at this point, sine is opposite over hypotenuse, and opposite is 1, hypotenuse is root 2, and therefore sine of angle 45 is opposite, which is 1 over hypotenuse, which is root 2. Now, in place of sine of 45, we are going to use 1 over root 2, and therefore we will have this expression here rewritten as root 8 over 1 plus 1 over root 2, so we have right there, and this can be simplified further as, so in order to eliminate the fractions on the denominator and the numerator, we'll have to multiply by the LCM, which is root 2 for this case. So root 2 multiplies the denominator, and we multiply the numerator by the same factor we've applied on the denominator, and that is root 2. So when we multiply the numerator, we have root 16, that is root 8 times root 2, that is root 16. The denominator, we have root 2 by 1, that is root 2, and then root 2 by 1 over root 2 is 1. This simplifies further to 4 over root 2 plus 1. Remember, root 16 is 4. Now, this can further be simplified by rationalizing the denominator, and this is what we are going to have. We are going to multiply the denominator by its conjugate, and the conjugate is root 2 minus 1. The same factor multiplies numerator, and when we multiply the numerator, we are going to have 4 root 2, that is 4 times root 2, and then minus 4, that is 4 times negative 1. The denominator, we apply a difference of 2 squares, that is root 2 squared minus 1 squared. Root 2 squared is 2, 1 squared is 1, and this simplifies further to 4 root 2 minus 4 over 1, that is 2 minus 1 is 1. So at this point, this can also be written as 4 root 2 minus 1, because the denominator is 1, that is the common denominator, and that is similar to having it as 4 root 2 minus 4. If you wish, you can also rearrange it as negative 4 plus 4 root 2. And there we have the final answer to the question. So that is it for this presentation. Thank you for watching. Hope to see you in the next video. Bye.